Okay, let's go ahead and get started. So a couple administrative items to address at the beginning of class. First of all, I hope you have textbooks. If you do, you should take a look. If you do, you should take a look at Chapter 3, whether it's of the Nicholson or of the Perloff. The chapter numbers happen to coincide. Our agenda today is going to involve a brief discussion of some of the trading results from Tuesday, and then we're going to turn our attention to a discussion of consumer preferences. So that's sort of the outline for today's lecture. Okay, a reminder also that problem set 1 is due Tuesday. It's extremely important, I said this before, I'll say it again, it's extremely important to turn problem sets in on time. We will not grade late problem sets. Poor Elliot over here. By the way, maybe you haven't met Elliot yet. This is Elliot Collins. He's our other GSI for the course. Poor Elliot has enough difficulties in getting all your problem sets graded, and we really can't and won't deal with problem sets that are turned in late. If you find yourself in a position Tuesday morning at 10:45 or so, and you find that problem set 1 really didn't get finished up over the weekend the way you thought maybe it would, and you've only got a couple questions answered, and there's a bunch of stuff that's left unfinished, turn it in anyway. I mean, don't just throw garbage in there, but an incomplete problem set that has 1 or 2 problems correct on it is considerably better than a problem set that has no problem set, which will grade as though it had 0 entries correct on it. Okay. Questions about administrative stuff or the problem set or what have you? Okay. Who doesn't have a textbook yet? Okay, a few of you. Any updates on availability? Is there? You haven't gotten around to it, or okay? So we're going to start using textbooks. So please try to acquire one of those soon. I've given the library my copy of Perloff's textbook. That should be on reserve shortly. So that's another way to get at these materials. The Nicholson, I understand, is already on reserve at the moment. Okay. Anything else? All right. Let's go ahead and get started. I want to point out a quote. Until a couple of years ago, so most of you are probably familiar with Shattuck Avenue that passes through downtown Berkeley and goes into North Berkeley. If you keep going north on Shattuck far enough, you go through a tunnel that goes underneath the traffic circle on the north side of Berkeley. The tunnel was originally built to allow the key train to pass through, but it was converted to allow automobile traffic a few decades ago. Anyway, on the side of the tunnel for many years, I think it's been covered up recently, was the following quote, the following aphorism: "De gustibus non est disputandum." And I don't know how long the graffiti had been up. I doubt it was since Latin was a commonly used language in this area. But anyway, can we get a translation of that? Anyone who has a little bit of Latin? Yes. Well, it's okay. The gustibus is related to words like gustatory and things like that. It has to do with your taste. So we'll go with likes. I like that translation. And I think you caught some of the spirit of the translation. But let's look at the rest of the words here. So non est disputandum. This is close enough to an English word that you've probably kind of recognized it. A really literal translation would be something like with tastes there is no disputing, and sort of a more typical, a less literal translation might be there's no arguing with tastes. Okay. So we're going to take that quite seriously, both in today's lecture and later on, and very much in the spirit of pursuit of positive economics. We're going to take as given the kinds of preferences or tastes that individual consumers have. And we'll return to that topic later, but economists are extremely modest in what we believe people ought to do. If you tell me that you like peas and not carrots, and somebody else likes carrots and not peas, I'm going to say, fine, de gustibus non est disputandum. So we're really quite modest in sort of in terms of trying to infer from people's behavior or even what they say. We'll try to draw inferences about what it is they desire. Okay, so that's a topic we'll return to later in today's lecture. Okay. All right, so I want to spend a few minutes talking about some of the data from the trading exercise we did on Tuesday. So is anyone who's here today not here on Tuesday? Okay. So you missed a fun time. Okay, I'll go ahead and describe what happened a little bit. So we traded claims to coffee contracts in the course of the lecture last time, and I wanted to spend a little bit of time talking about. And I made a prediction about what prices were. So I want to tell you a little bit about how I made that prediction, and then I'll use a little bit of data from the actual game. Okay, so here's the idea, and it appears to me that this graph didn't come out at all. Let me look again at my laptop. I'll have to fix that. But let me show you. We started off with some primitive data. Let's think about supply first. So you'll recall that last time sellers used red cards. So what I have here is just a schedule of the number of red cards of different values that we had in the experiment. So in this example, we had 6 red aces, we had 6 red twos, and so on. We had 6 of all these things. So no, these numbers could have been different in this example or not. Now we're going to use those to construct a supply schedule. And the way we'll do this is to look at the schedule. And for the supply side, we'll start with the seller who has the lowest cost. And we'll say, or even less than that, we might say, well, gee, at a price of 0, so I'm going to draw this on the board. Let me fix this. Okay, so keep your eye on that supply schedule. I'm going to draw a supply curve of the sort that you've seen, in EAP1, for example, or some other intro economics course. So we're going to have quantities of coffee on this axis, and we'll have the price of coffee on this axis. And this table we have here gives us the primitive data we need to construct the entire supply schedule that we faced during the exercise we did on Tuesday. So here's a way to think about this. Let's start with the price of 0. Let's say this is the origin. Now, how many sellers would have been willing to sell at a price of 0? 0. So the supply curve passes through 0. At a price of 0, the total quantity will be 0. Okay. How many sellers would have been willing to sell at a price of 1/2? Again, 0. So this supply curve, it's not really a function, you can see, because it's got this vertical part. So let's say this is 1. I'm going to say this is 1. This thing's going to go up until it gets to 1. It'll be 0. The total quantity will be 0 here. Now, when we get to 1, how many sellers would be willing to sell if there are 6 sellers with an ace? A total of 6. So as soon as you get to 1, the supply schedule bobs out like a staircase until we get to a total of 6 here. And so we've got sort of one stair in this funny supply schedule. Okay, now suppose the price was 1.5. How many sellers would be willing to sell at that price? You guys are a quick study. Still to 6, and that'll be the case until we get up to 2. When we get to 2, how many will be willing to sell? 12. Oh, very good. Okay, so I'm going to cut to the chase here and assert that with this supply schedule of 6 of each of these values, we're going to get a staircase shape of this thing, like this. And the staircase is what this figure here is would look like if it were clear stuff. So I'm not sure what happened there, but anyway. So we get a staircase sort of shaped supply schedule. Now, staircase-shaped supply schedules are probably not quite what you saw when you talked about supply in an intro econ course. Can you tell me why? What's different about this case and what you may have studied before previously? Yes. Let's back up a moment. So if I said draw a supply and demand schedule without any sort of other guidance, what would you draw? Yeah, probably something maybe linear for sure, not without those bumps. So I bet that if you took E1, you saw schedules that look a lot like that. Now this kind of captures this goes up and it's connected, but it's sure not a straight line. Yes. Okay. Actually, we're allowed to go in cents. So actually, we had lots of trades at like 550 or so on. So those prices were allowed. Okay. So yeah, actually, so what's your name? Shu. So Shu says, well, the costs have this underlying lack of continuity. They only come in discrete quantities of an ace, a 2, a 3, or 4, or so on. So that's absolutely right. We have a sort of discrete description of the cost at the Sellar space, and because of that discreteness, we wind up with this staircase sort of story that we observe here. Now, that doesn't mean that, so it's a little bit funny that we have staircases here, but in the real world costs that firm space, it's not clear those are going to be continuous either. At least they're going to be denominated for accounting purposes in dollars and cents, and those are also discrete. So it might be, you should conclude that supply curves don't have to be linear. That's just kind of convenient, maybe a convenient approximation. And that whether or not this has staircases or whatever depends on the underlying costs facing the firms that are actually providing the supply of goods. Okay, so that's the supply schedule. Any questions about that? Yes. Oh, that's a really good question. I should have said before. So that's the cumulative is what I meant for it to stand for. So it's the cumulative sum of all these sixes. And in this case, you can see it is. And so what it tells us is, at a price, if I do this correctly, I should be able to look it up and say, well, gee, at a price of 7, the total quantity should be 42. So if I did that, let's see. 1, 2, 3, 4, 5, 6. Oops, I need one more. 7. This should be 42 here. Yeah, thanks for the question. Okay. Clear enough? Okay. I think problem set 2 may ask you to construct a supply schedule along these lines, so make sure the details are right. Okay, so that's supply. You might guess that, I had fun making this graph. So here's how this is actually physically how I constructed the supply schedule when I was trying to make my prediction. I took the cards that you had, and I laid them out, and I had however many aces, and I set them off so that they're 1 unit apart. So if I had 6 aces here, this gives me 6 units, and then I had some 2s, and I laid them out, and sort of kept going across, 3s, and that's how I constructed my supply schedule. And then I did the same thing with demand, and I looked at where the things crossed, and I could see they crossed at 5.5, which is why I gave you the prediction I gave last time. Okay, so you can do something similar for demand. The only trick with demand is, that we sort of asked this question to construct the supply curve. We said, how many sellers would be willing to sell at a price of 0? And you guys correctly said 0. We can't ask that same question about demand. If I said, well, I guess we could, but it would be a little funny. If I said, how many people would be willing to buy at a price of 0? Then all of them, or infinite number or something. It's not a clean-cut question. A better question would be to ask for constructing demand, how many people would be willing to, or how much would be demanded at a price of infinity? Okay, so go ahead and answer. 0. And so the demand schedule here, in this example, is going to be 0 until it gets down to what number? Until it gets down to 10. At 10, so the demand schedule sort of never peters out. It goes up to plus infinity. It's defined for prices anywhere between 0 and plus infinity, no problem. But it just follows the vertical axis. Once it gets down to here, it pops out to, what do we have? Again, 6. And then, so 6 people are willing to buy at 10. How many people are willing to buy at 9? At 12, so here we go. Thus, and I'm not going to draw this correctly. This exceeds my abilities. It exceeds my abilities because these things line up here. Somehow. Like that, I guess. Oh, there we go. Yeah, this line up like that. Okay, so in this case, we got an intersection. I said 5.5. That actually wasn't quite right. Really, what happens is there's this intersection in the interval between 5 and 6. And so I said 5.5 to explain the difference. But actually, there's not really a sharp prediction about where it's going to lie between those two numbers. There's a sharp prediction about quantity. That's whatever this is. At a price of 5 or 6, we should see 36, I guess. So there's a sharp prediction about that. But there's going to be some variation in price. So it'll be somewhere between 5 and 6. And that should be 36 there, I guess. Okay. Reasonably clear? Yes. Yeah, that's right. I think that I think that somebody came in a little bit late, and maybe somebody left a little early. The number of cards we had out there changed just by 1 or 2 cards across the different rounds. But yeah, we wound up with very similar numbers of trades. And I think if the composition of the room hadn't changed, we should have had exactly the same number of trades each round. As it was, we were off by 1 or 2. But yeah, so the prediction here was 36 trades. I'm not sure if we ever got quite 36. Partly that's because, remember, I didn't deal out all the cards I had. So this is a prediction. If the room I came in here with something like 100 cards, if it had actually been 100 people, this would be the prediction. There's fewer of you, and some random set of cards got left out, so we will have a little bit less. Okay, other questions? All right. So I had you guys, this is terrible. I need to work on my figures. Okay, so here's the actual data from the first round of trading, with a little bit of uncertainty about the timing. But basically, there's 3 lines here, which I wish you could see better, but here I'll do my best here. So there's 3 lines. The top line here is the value to the buyer. So you can see it's a high number. The very first trade that happened here happened and involved a buyer with a value of 7, it looks like, if I'm reading this correctly. The blue line here at the bottom reflects the cost of the seller. And so the seller in the very first trade had a value of, I guess, 3. And then the green line in between is the price they agreed on. So, someone tell me how I can figure out profits for, let's pick this trade here. What are the profits for the buyer and the seller? So the price here is 7. What are profits for the seller? It looks like 1. So the seller had a cost of, the buyer had I think I said that backwards. The buyer had a value of 8, the price was 7, so the buyer had a profit of 1. The seller here had, is that the same distance? Oh, maybe it's 550, or maybe that's not 7. Maybe it's 750. Okay, so then 50 cents here, and then I guess 3 times that here, so $1.50 for the seller. Maybe I should choose a different example. Which trade do you think involved the largest profit for either buyer or seller? Maybe this one here. Looks to me like there was a seller with a cost of with an ace who was able to sell at a price of 6 or maybe even 6.50. I can't quite tell there. The buyer of that transaction made a profit of 50 cents. Okay, is that clear? Can you even read the graph? I can sort of read it here, but I'm close to here. Okay, I'll put this stuff up online too. The PDF you'll be able to look at your computer should be clearer. All right, so let's proceed. Then. So I guess one other thing I would say about this, the price that was realized bounced around some, and yeah, I think I even remember this 750 when it was announced, perhaps during this first round. It always lies weakly inside this interval. Partly we're enforcing that. We weren't allowing people to sell for more than for less than their cost or to buy for more than their value. So the green line has to lie inside this interval defined by the blue and red lines. Okay, that's what I have to say about that. We also figured out. We also asked you to record your individual profits. So I went and then you added them up. I went through and entered those data. Here they are. So this is a histogram of profits, where each one of you is an observation. And so you can see the lowest profit that anyone recorded was, I guess, 3. The modal profit was something like 4. This I'm not sure why there's such a big spike here. The largest profit I think was 17.5 actually. And this is the distribution of things. So who had the 17.5 profit? What's your name? Katie. To what do you ascribe your success? Okay. I think it's not enough to get nice cards. I actually noticed something else in this figure. I've just gone back a slide here. If you look at the very last trade here, it's a seller who has a value of 2. And so if you come in with a 2, you would expect to make a pretty decent profit. This is somebody who waited too long. By the time they were, the clock was called, they had to make whatever deal they could, and that was somebody who had a value of just 3, I guess. So they made a profit of 50 cents there, I think. So it can't just be luck. It's also timing, at least. Okay. Anyway, so here's the distribution of profits. Yes. Oh, yeah, I can do that. Thanks. Okay, is there anyone? Katie's been modest about this. Is there anyone else who feels like if we did that again, they're pretty sure they could earn more than average profits? Anyone have a system? Yeah. Uh-huh. Gotcha. So if you did it again, you'd yeah. Okay. Anyone else? Anyone else have advice to offer about trading in the fake coffee pit? Yes.
Generally, just because being able to value list like 550, so if you were a buyer, I would start off by asking for 5 or 4, and if I was seller, I'd start off by asking for 6.
Uh-huh.
Instead of that.
Okay, good. That sounds related to this earlier point. What's your name? Tom. So Tom was saying he was asking too high, so maybe he was following a strategy of saying really want to get 3 instead of being willing to settle for 4, and those deals evaporate pretty quickly because there's a lot of people who want to be able to sell at this lower price. Yes. Oh, good. That's right. Actually, we had an example. I'm going to pick on you two, I think. We had an example in front here where these two settled at the very beginning. I think you had a 2 and you had a 3 or something like that. And they just didn't want to get up and mingle. So that's okay. I mean, you might regard part of your cost as not only the cost involved in the card, but also the cost of hauling yourself up and walking around and talking to people. Those costs probably aren't 0. Yes. I like that. So Chu observes that if you're a seller, you observe a cluster of other sellers, you probably shouldn't go hang out with them. You should go to someplace where there's a cluster of buyers and exert a little bit of local market power. Yes.
Also on the collusion round, if you need to kind of deal something, they all sell really cheaply right now. In the next round, you have better cards to do that, and that's like real world. People make companies with deals, and maybe one company will profit really high in this deal, maybe you can profit really high in the next deal.
Okay, good. So what's your name? Brian. So Brian observes that, or he's thinking about the collusion round, which I want to come back to actually in a moment, and suggests that you ought to be able to use, an economist way of putting this is that you might be able to use dynamic incentives in order to increase your profits in a situation where there's collusion like that by using payoffs in different rounds. So you can sort of take turns making a large profit perhaps and mutually benefit. Now the entire class couldn't mutually benefit from that. And this is a zero-sum game in a way. Or it was not really a zero-sum game. It was a fixed-sum game. So the total payoffs across the class didn't depend on your behavior. Only the allocation of those payoffs did. Okay, but yeah, I want to come back to the collusion round. Anyone have any thoughts about how the collusion could have been made to work differently or better? We wound up, let me remind you, in the collusion round with an average price at least, which was very similar to the competitive rounds. So what? Seems like collusion might lead to different prices. Yes.
I think there's nothing that helps accountable to the agreements that were made, so we'll just do whatever was best in the case of
We need some enforcement. Yeah. Yes. Okay, so this is related to, thank you. So this is related to a suggestion I had that involved just being able to more easily search for people who had a certain value of card. And in the collusion round, that might well have worked because different individuals had different incentives, either to go along with the informal agreements that I think both demanders and both buyers and sellers forged, and different incentives also to chisel. So actually, that's worth asking. Among the sellers,